Download this code from codegive.com, link in the description below. Analog input scaling in Delta PLCs is a crucial process that allows you to convert the raw analog input values, typically from sensors, into meaningful engineering units. This tutorial will guide you through the concept of analog input scaling and provide a code example to illustrate the process. What is analog input scaling? In many applications, sensors provide analog signals that represent physical parameters like temperature, pressure, or flow rate. These signals are often in the form of voltage, 0-10 V, 4-20 mA, etc. The raw values read by the PLC from these sensors need to be scaled to represent real-world values. This process is known as analog input scaling. Steps for analog input scaling. 1. Identify the range of the sensor, determine the minimum and maximum output of the sensor, example 4 to 20 mA corresponds to 0 to 100 degrees Celsius for a temperature sensor. 2. Define the desired range, define the real-world range you want to convert the raw input into, example 0 to 100 degrees Celsius. 3. Use the scaling formula. The formula used for scaling is backslash text scaled value equals left, frac text raw value, text raw min text raw max, text raw min right, times, text scaled max, text scaled min, plus text scaled min. Example scenario. Let's assume we have a temperature sensor with a 4 to 20 mA output that corresponds to a temperature range of 0 degrees Celsius to 100 degrees Celsius. Raw input range, 4 mA to 20 mA. Scaled output range, 0 degrees Celsius to 100 degrees Celsius. Step 1, define the constants. Raw minimum, 4 mA, equals 0. Raw maximum, 20 mA, equals 100. Scaled minimum, 0 degrees Celsius, equals 0. Scaled maximum, 100 degrees Celsius, equals 100. Step 2, example code in Delta PLC, WPLsoft. Here is an example of how to implement analog input scaling in a Delta PLC using WPLsoft or a similar programming environment. PLC / constants for the sensor. Define raw _min 4.0 / minimum raw value, 4 mA. Define raw _max 20.0 / maximum raw value, 20 mA. Define scaled _min 0.0 / minimum scaled value, 0 degrees Celsius. Define scaled _max 100.0 / maximum scaled value, 100 degrees Celsius. / variables. Real raw value, / input from the sensor. Real scaled value, / scaled temperature in degree C. / assume raw value is obtained from the analog input channel. / for example, using an analog input channel, example AI0. Raw value equals AI0, / read raw analog input from channel AI0. / perform scaling. Scaled value equals, raw value, raw _min, / raw _max, raw _min, asterisk, scaled _max, scaled _min, plus scaled _min. / output the scaled value to a display or use in further logic. Do 1 equals scaled value, / output the scaled value to do 1 or display. Explanation of the code. 1. Define constants. Constants for the raw and scaled ranges are defined using define for easy reference. 2. Read raw value. The raw value is read from an analog input channel, AI0 in this case. 3. Perform scaling. The scaling formula is applied to convert the raw value to a scaled value. 4. Output the scaled value. The scaled value can be used in further logic or sent to an output device. Conclusion. Analog input scaling is an essential technique in automation and control systems to ensure that raw sensor data is converted into usable engineering units. By following the steps outlined in this tutorial, you can implement analog scaling in a Delta PLC effectively. Adjust the constants according to your specific sensors and desired output ranges.